Thank you. Thanks for having me. So my name is Ville Tuulos. I'm a co-founder CEO at Outer Bounds, where we actually develop human-friendly production-ready infrastructure. But today I just wanted to give you a quick tour of Metaflow, which is an open source project today that we actually started at Netflix already about 4 years ago. So I want to start with a little story here. So as many of you know, Netflix has been doing personalized recommendations for a long time. When you log into netflix.com, you can see all the TV shows and movies shown to you there on that grid, and that's of course powered by machine learning. But at some point, like I said, about 4, maybe 5 years ago, it became obvious that the company has many other machine learning use cases as well. It's really a diverse set of use cases that really started popping up across the company. And like you can think of use cases like natural language processing. Of course, the company deals with a lot of unstructured text, even screenplays and so forth. Or it might be something really business related, like predicting churn, who's going to keep using the service and who's not. Or it might be something that's technically not even machine learning, but mathematical optimization, operations research, namely how to optimize production schedules. Or of course, like company that has so much video material, I mean, has many use cases for computer vision as well. So like a very wide array of different kinds of use cases. And now, of course, a question that like many companies have been asking themselves, and like many, even us as an industry have been trying to figure out that what is really common across all machine learning projects, like which we could provide as a platform. So I was leading the machine learning infrastructure team at Netflix, and of course, the kind of a question like that we were asking ourselves is that like, how can we help all these data scientists working in different machine learning data science problems in being as productive as possible, so that they wouldn't have to reinvent all the wheels every time again and again. But I mean, at the same time, it's a very diverse set of use cases, so it is not so obvious that what are really the commonalities. So when we started thinking about it, it's easy to see that like one of the things that's absolutely common across all projects is that all projects deal with data. So if you are dealing with computer vision, it might be images, it might be videos. Natural language processing might deal with unstructured text, like churn prediction might be metrics. Other projects might have relational tables. But I mean, it's data, like in all cases, in any case. The other thing that's really like a defining feature of data science is that you want to perform some non-trivial amount of compute. You want to do something with data. And maybe in contrast to classical business intelligence and analytics, these algorithms employed by machine learning and data science are oftentimes quite compute intensive. Indeed. So of course, like computer vision is famously hungry with deep learning, and the same thing with modern and natural language processing, and even like traditional machine learning takes some compute power. So you need access to some kind of a compute resources. The other thing that becomes quite obvious, like when you start building these real world applications, that it's not only about building a model and training a model on this compute platform, but every real-world application consists of multiple steps that are connected together. It might be that first you are receiving the data from some data warehouse, and maybe then you are doing multiple steps of data pre-processing. And after that, maybe you're training model, maybe you're training multiple models, maybe you're conducting hyperparameter search, and then like choosing the best model and so forth. So you end up like with this kind of like a DAG, like a workflow of different kind that describes the full end-to-end application. And now, for all of you who have been working on real life data science projects in the past, you know that like you never get it right like from the get-go, and even building the whole workflow takes multiple iterations. So instead of having a single workflow, you actually have multiple iterations of the workflow. You start with something, and then you realize that something is missing. You add new steps and so forth. So you kind of need to keep iterating. You need to keep adding like new versions, and like kind of keeping track of these versions as well. And of course, like it might be that there are even multiple people involved. So maybe you have a whole team working on an application, each with their own version. And then something that's also like absolutely significant these days in these projects is that there are amazing off-the-shelf libraries available, like PyTorch or like stats models, so scikit-learn, TensorFlow, and so forth. And well, these libraries, of course, give superpowers to people, and it's just amazing like what you're able to do with them. At the same time, they can give a bit of a headache. They are fast-moving libraries. They are not always perfect, and especially like when something is in production, you absolutely want to make sure that like any changes in the library don't negatively affect your production pipelines. So now when we were looking at this picture and like thinking about these common elements, we started thinking that, okay, like if these are indeed the commonalities between all the projects, would there be a way how we could address these concerns in a single coherent framework? Because it does feel that these concerns are quite universal. So even though there's a big difference between NLP and computer vision and churn analysis and so forth, if only like we could provide this like a foundation like for all the projects, I mean, then they could like kind of do their modeling on top of the foundation. And that was really the motivation like for Metaflow that we started building in the first place. And like with Metaflow, we took this approach that like we really want to address the full stack. And the stack contains all the elements that I mentioned, like the data, compute, workflows, like versioning. And then on top of the stack, there are like concerns that, okay, how are data scientists, well, oftentimes not software engineers by training, how should they even architect the full application? And on top of that, like how do you operate the application in production? Of course, this contains questions like how do you deploy them reliably? How do you monitor the models, so forth. And then of course, on top of this stack, I mean, you have the actual kind of the core concerns of machine learning, namely feature engineering and model development. So when you kind of like look at this picture like from the data scientist angle, oftentimes it's really at the top of the stack. You have the concerns that the data scientist is really interested in. So I mean, you want to really focus on the question of model development. You want to focus on like engineering the best possible features for the models. Maybe you're also interested in understanding like how you can really monitor the model in production, deploy it reliably, and so forth. But then at the very foundational layers of the stack, there's a bit of a feeling that these basic questions like, okay, how do I access data from the data warehouse? How do I get access to compute resources? How do I orchestrate workflows? They're like engineering concerns that like should just work, and the data scientist like should get them kind of off the shelf without too much headache. And hence like our point of view as we were an infrastructure team was that like, okay, so our help is most needed at the lower layers of the stack, whereas then the data scientist can have more freedom to do kind of whatever is the right thing to do, like for their project at the top of the stack. Okay, so what does this mean concretely? So I don't just want to kind of wave hands about this like a general like what do data science projects look like at the high level, but I mean like kind of let's go into more details and see how it works. Now, the thing that like we have recognized from the very beginning is that oftentimes people talk about this project lifecycle, end-to-end data science going from prototype to production, and as if it was a kind of a single kind of linear journey that you just flip a switch and you go from prototype to production. But in practice, it is a journey. There are multiple steps, and also what is meant by production is actually quite diverse. So there are many different kinds of production, and as we very well know, there are different kind of SLAs, different service level agreements, different expectations for different projects. So whereas let's say recommendations at Netflix may be really highly sensitive, it must always work, it must always produce the correct results. There might be some, let's say, new experimental computer vision application that has much looser requirements, and hence also like it shouldn't have like kind of all the same necessarily checks and balances and so forth to kind of burden the project like in the early phases to make sure that like kind of it hits some targets that are really not relevant for the project. So like what does this journey look like in practice? Well, I mean, starting like from the very beginning, I kind of drew this laptop here on purpose because there's the question that like, how do you even develop this code? How does data scientists work in practice? And of course, it might be that like you just have your laptop and that's all you do. But then like at one point we noticed that it's actually like quite convenient to provide these cloud-based workstations. And what I mean by that is that imagine that like you're a data scientist here on your laptop, but then like pretty much always these days the actual production environments exists somewhere in the cloud. And even more so, it might be that your laptop is maybe an Apple laptop, maybe it's running OS X, and then the production environment runs Linux. So there's quite a gap between your test environment and the production environment. And of course, like as we know, that causes all kinds of challenges. You may have different packages locally, and like the production environment has much more resources available and so forth. So the idea was that, okay, let's make this cloud workstation available that is equally available in the cloud. It also has the same operating system. We can easily like kind of provision more resources there. And like overall, like when it comes to kind of just maintaining the unified data governance policies and security policies and so forth. It's easier to make it happen on this like a cloud workstation. So that's something to think about, that we were like very successful with that. Yeah, of course, these days many different ways how you can make that happen, and I think like with like many things like GitHub or code spaces and so forth, this approach is becoming more and more prevalent. Well, now the next thing that pretty much everybody does, like in the realm of data science and machine learning, is that like the exploration starts with notebooks. So notebooks are really great for this purpose. You can just like look around in data, you can see what's going on. But also, like as many of us know, these notebooks can get messy, and it's actually like not so much the notebook's fault by itself. I mean, there's nothing wrong with the tool, but it's the fact that like the exploration is the mindset that like you are not necessarily like building anything like a robust software artifact, but I mean, you are just like kind of really exploring. You are kind of looking around. You are like kind of looking at the projects from different angle, like prototyping stuff quickly and so forth. And the end result is never supposed to be something that's super production ready. Nothing wrong with that. But at some point, like you get to the point that it makes sense to start putting together something that's a bit more production ready. And like by this, I don't mean anything too crazy, but I mean this basic idea here that like instead of like just having your Python code as cells in a notebook, you can structure them already as a workflow. So this is a very simple, actually fully functional, but very simple Metaflow workflow. So what you can see here is that this is a Python class. It just derives from this flow spec. So Metaflow knows that this is about Metaflow. And then you have these two steps here. You have a start and end here, like on the DAG visualization as well. And you can see that there's an arrow between start and end, like which is actually denoted by the self.next. And then like within these steps, you can like really literally like write any Python code. So you can even copy paste cells from a notebook and put it there in that step. So in a sense, the kind of the gap between the notebook and then taking this workflow approach is actually quite small. I mean, you can basically take the cells. I mean, you could imagine that like you have some code in the first cell and you copy it to start, and you have some other code in the next cell and you copy it to end, and like off you go. And Metaflow provides this command line interface, so now you can just execute it on your local machine. Let's say like doing the Python myflow run, and it actually like just executes the DAG. So you don't need to deploy anything. You don't need to know about any other system. You don't need to write any YAML files. It just works out of the box. So that by itself, I mean, doesn't seem that special. But this is really the foundation upon which like everything else builds. So one nice thing about like just doing the workflow thing is that Metaflow actually now starts tracking all the executions. Every single step, every single piece of code that gets executed gets logged and stored and persisted in Metaflow's data store. And the benefit of that, besides, of course, now I mean like being a bit more organized, is the fact that you can actually use, let's say, notebooks or like different UIs to kind of look into what's going on in these workflows. So not anymore you are flying blind and like just like clicking run in a notebook without knowing like what happened in the past. But I mean, now you have this kind of like a full history of all executions, which is a form of experiment tracking. But I mean, not only we are tracking the experiments at the model level, but we are also like looking at the code and also like the data that goes inside those workflows. And this is, by the way, how the Metaflow GUI that we released last fall looks like. So here, like for instance, like you can see like how long each step took to execute, and like you can see what's going on in each step and so forth. So now another extremely useful feature is that you can also now start scaling each of these steps individually. So for instance, here, many of you may have been in a situation that, like, let's say you have some decent sized data set, but maybe not like a massive scale. I mean, we are not talking about terabytes here, but let's say you have any kind of data set like that's, let's say, in the order of like tens of gigabytes as compressed files, and then when you load it in memory, I mean, like maybe it takes like 60 gigabytes, and most likely that is more than like what you can handle on your laptop. So if you just load a data frame like that in memory, I mean, kind of a notebook is likely to crash. But now what you can do is that you can add this add resources decorator in your code and say that, oh, by the way, this data frame requires 60 gigs. So maybe just in case, like we add a bit more headroom there, and like we request 128 gigabytes of RAM. And now, of course, like magically, like we can't make more RAM available on your laptop, but what we can do is that now when you run with batch in this case, we can actually leverage this service called AWS Batch, which then like on the AWS on the cloud side provisions instances on the fly. So you don't have to worry about the servers. You don't have to worry about the EC2 instances. It does it automatically, but it makes sure in this case that like there's 128 gigabytes of RAM available. So you can again start this on your laptop, but now instead of executing this function on your laptop, it actually executes in the cloud using an instance that has the kind of the requested amount of memory available. So that is super convenient. It's basically kind of giving you a big button, like where you can just have a bigger laptop. So that's super handy. And of course, like the really the key feature here is that in contrast to many other systems like Spark, for instance, is that you don't have to change anything in the code. I mean, this is still exactly the same Python code that you are executing locally. It's doing nothing magical behind the scenes in that sense. Like you can use any Python libraries, everything, it just works. It just like runs on a different machine. Another way of doing scalability is that not only you can have a single bigger instance, but you can have multiple instances. Like that's called horizontal scalability. And what you can do in Metaflow is that you can say, like for instance here, that like we have some params variable in Python, like we say that okay, let's put any Python list there. Like in this case, we just have numbers between 0 to 99. And then we say that, okay, let's do for each over these params. And now what Metaflow does under the hood is that it actually kind of fans out the next step, in this case, the train step, to have 100 copies running in parallel. And again, I mean, you can do this in the cloud. So of course, like if you were doing this on your laptop most likely doesn't have 100 CPU cores, and especially like it doesn't have like 100 CPU cores with 128 gigs of RAM each. But obviously, this is something that you can do in the cloud. So now when you run with Batch, we farm out the compute, and all these steps now run in parallel. And now you can imagine that, like for instance, these 100 things might be like a different model training steps. Maybe you want to train the model for 100 countries in the world, and it's just very convenient that all of them happen in parallel instead of sequentially. And now I just wanted to highlight that the feature that we just released a few months ago also allows you to leverage existing infrastructure, namely Kubernetes clusters that your company may have set up. So if you're a data scientist, if you don't know like what Kubernetes is, I mean, don't worry. I mean, the only thing that like you may kind of want to have in your code if you work in such a company that uses Kubernetes is that you can do @Kubernetes and nothing else. I mean, it's still the same code. The only difference is that now instead of scaling out to AWS Batch, we can scale out to the Kubernetes cluster. And this is a feature that many companies are very excited about, especially engineering teams, because they have already made investments in setting up these clusters, and now they can just leverage them for data science as well. Another interesting question comes up when you start farming out the compute to the cloud, which is namely that how do you access data? And now you can imagine that, let's say, like we do this 100 way for each, and like you have, let's say, a database. And now if each one of those steps hits the database concurrently, it might be that the database administrator is not too happy about it because you're basically like causing quite a tremendous amount of load to the database. So one pattern that like we have been using quite successfully is that, like for instance, in the kind of the start step, or like in any kind of data pre-processing step, you can execute some piece of SQL. You can do kind of a data pre-processing using your data warehouse, and like you can, for instance, do this like a create table as select queries, which means that you kind of like create this kind of a intermediate or temporary table. You run the SQL first once, and maybe even so that you partition the table according to the kind of the sharding, according to the for each that you want to execute. So maybe you create this temporary table that has this one partition for every country in the world, and now then when you farm out these individual, let's say, like a training node, so like in this case, load data, you can then like load that partition as a Parquet file directly from S3. And one thing that I want to highlight here is that Metaflow comes with this built-in S3 client that you can just use like from Metaflow import S3 that is highly throughput optimized, meaning that it actually can load data very fast, like from the cloud, meaning that like you can even download large data sets in a few seconds, like up to, actually it's more than like 20 gigabits per second that you can get these days on a large instance. And although this may seem like oddly technical, the fact is that this was actually like one of the most loved features of Metaflow inside Netflix as well, because it meant that instead of having to wait for data to load for a long time, the data scientists get it like really, really fast on their experiments. By the way, this works in notebooks as well, so you can benefit from that locally as well, or on your cloud workstation rather. Okay, so let's say that like at this point we have a workflow that is able to scale out. It's even able to load data quickly. It can train the models. The next big question is that this far, like we have been writing that like a Python MyFlow run on the laptop, but of course, in the kind of a long term, like you don't want to be like running things on your laptop. You don't want to even like start the execution on your laptop, but the orchestration, the scheduling should happen somewhere else. And this is really a key part that we really like the idea that you are like retraining the models at the regular cadence. It shouldn't be a special operation. It shouldn't be a scary operation. It should rather be something that like happens automatically, let's say even every day. Even if you don't need the model every day, I mean, it's useful to do it regularly. So if something fails, you can catch that early. So how does that work? So now Metaflow integrates with a number of off-the-shelf workflow orchestrators. So some of you may have heard of systems called Airflow, and there's another one called Argo, and there's yet another one like called Step Functions provided by AWS. But all these systems basically do the same basic idea, which is that like you give them a DAG, you give them this workflow, and then they take care of like executing, orchestrating the DAG, like executing each step one at a time. At like whenever they need to be executed. For instance, like you can, in the case of Metaflow, just write Python myflow py step functions create, and this will take the Metaflow DAG, exactly the same DAG that you wrote and you tested locally with Metaflow, but now translate that to a format that's used by AWS step functions, and then kind of push the whole thing to the cloud. And what that means is that you are not on the hook anymore for executing the whole thing by yourself, but it can, let's say, like run automatically every hour or so, and then you just get notified if something gets wrong. And the key thing here is that like you don't have to change anything in the code. You don't have to write new configuration files, especially like in the case of step functions. I mean, they use this like a very verbose JSON-based configuration to create these things. So it's really not that fun to write by hand. Or if there are like other systems like Argo workflows that like runs on Kubernetes, it's the same idea. And Argo like requires these YAML files, and like many of you may have written YAML files by hand to define the workflows. And again, it kind of feels a bit like a busy work, because our vision is that like you first need to be able to test these full workflows locally and even scaling out to the cloud. But then like when it's time to go to production, you don't want to kind of start like writing like complex YAML by hand, but it should be really just a click of a button, like what happens here. And by the way, like for those of you who are using Airflow at your company, like we have this Airflow integration like coming up, hopefully in a few months. So then like you can basically write the workflows in Metaflow. You can test them locally. You can benefit from all the features of Metaflow. But then like when it comes to scheduling these workflows as a part of the wider, let's say, data engineering, data science ecosystem, you can just like run this Airflow create, and like off it goes to the production scheduler. An interesting failure type that we faced then when we started scheduling these things in production is that imagine this scenario that you have a machine learning workflow that, let's say, uses some Python library. I mean, there are like all kinds of Python libraries that are like useful for data science machine learning. I mean, like besides the big ones like PyTorch, there are like many small libraries. We actually like happen to use this one called Fancy Impute, for instance, for data imputation. It's a library. You can find it on GitHub. And now one day this library released a new version, and that new version was a bit broken. And like when like kind of our workflow that run on regular cadence like ran again, I mean, it actually failed because of this library difference. And now many of you may solve these dependency questions by creating Docker images. But then the problem becomes that, okay, so let's say like who gets to build these Docker images, and is it the responsibility of the data scientist? Is it the engineering team? And like, are you going to have a different Docker image for every project, like, or like should everybody agree on the same versions and so forth? And that's actually a surprisingly tricky problem. And to address this question, like what we did is that we integrated this package manager called Conda in Metaflow itself. Many of you may have used Conda by hand, but like when you use Conda with Metaflow, you don't have to create any virtual environments by hand. What you can do is that you just do @conda and you define the library dependencies. Like let's say in this case, I need TensorFlow 2.5. I can just say that, okay, I know that like every time this step executes, I will need TensorFlow 2.5. So that's like kind of what's always needed. And now like there's actually quite a bit of magic that like happens behind the scenes when you do this. Well, I mean, first when you run that locally, Metaflow takes care of setting up all the virtual environments for you, so you don't have to do it by hand. And this is especially convenient if you happen to have different dependencies for different steps. You don't want to manage like too many virtual environments by hand. It gets inconvenient. But even more so, like when you export something to production, like to the production orchestrator, Metaflow will actually like resolve the kind of the whole dependency graph, including all the transitive dependencies of TensorFlow, load those packages, cache them in S3, and now anytime you execute the code in the cloud, you are guaranteed to get exactly the same environment, even including exactly the same transitive dependencies than what you run locally. So now what it means is that you get this fully frozen, like stable execution environments, like for production runs. And this was actually something that we felt quite strongly about, that when something is in production, we don't want any surprises to happen. And oftentimes those surprises happened. Of course, like one of the common sources is about data, but the other one is that like something in the execution environment changes. So it might be that like a TensorFlow changes or some other library changes, or it might be that it's not even the library itself, but some other library that like that library uses some transitive dependency. So we want to freeze all those things. But also we wanted to make sure that like maintaining Docker images, let's say, doesn't become a burden for data scientists, and like it also shouldn't become a burden like for engineering teams, who in our case actually like kind of had quite a pickle because different projects had different requirements and they didn't want to have start maintaining Docker images for every project separately. Now, the next question like after this is that, okay, so we have this production ready workflow now running in the cloud. Of course, the question is that, okay, so how do you know what's going on? And now there are many different ways to do this observability, many different things that you want to observe. I quickly showed you before that Metaflow GUI, so you can see like how all the workflows are executing via that. It applies to production runs equally well as the local runs. And of course, like many of these workflow orchestrators like come with monitoring tools of their own. But then like when it comes to monitoring like what's going on inside the machine learning models, of course, like there are many tools available, and like some of you may have used some tools like weights and biases, or like Arise, or like many other model monitoring tools. But one kind of like maybe a bit complementary use case that like we have observed is that like besides like seeing what's going on in the models themselves, oftentimes there are maybe some like more business metrics that you want to observe, or maybe they're like really a need for these lightweight report cards that you want to attach to the workflows. So for instance, like when we were working with data scientists and asking like what kind of monitoring needs they have, of course, they had like, especially during development, they wanted to use something like TensorBoard or like weights and biases, maybe to see how things are converging. But especially when in production, then the kind of focus shifted more on the kind of a business KPIs and seeing like kind of like what's going on overall in the whole workflow, not only in the model itself. And now there's of course an absolute like infinite number of different dashboarding tools available. So it's not the question of that. We, for instance, like we use Tableau, but like one challenge is that like first, I mean, like you need to learn another tool, but like even more so, like the question is that like how do you then like connect your dashboard to your workflow? And like again, I mean, this was like another hassle that like you could of course like write the results like to some kind of a table, and then the table is loaded by your dashboarding tool and so forth. But I mean, there are like surprisingly many steps involved there. So now what we wanted to do, and like what we released last like end of last year in Metaflow, is that there are these like very simple things called Metaflow Cards that are basically static report cards. So these are not interactive dashboards, but like oftentimes these are exactly the kind of the simple thing that you need, which is that like you can have just this this add card decorator in your workflow. And then there are like these very basic components that you can have in your report card. Like you can include tables, you can include images, and especially you can include any kind of like plots in the charts. You can use any plotting library of your liking. And like the most important thing about this feature is that now Metaflow itself guarantees that like anytime the step executes, then the report card gets created. So you always have this one-to-one correspondence between the code that gets executed and then the card. And like what's really an important corollary of that is that these cards also get versions. So like as I mentioned, Metaflow versions all these executions. So now every single execution, both that's happening locally as well as in production, has these report cards, and like they're all stored, so you can also like compare them over time. So actually, like I was just like using that yesterday, and again feeling that, oh, actually this is one of my favorite features. Like actually, like even during prototyping, because I can just like quickly run with card and see what's going on. Okay, so now we are like approaching this like ultimate nirvana of like production readiness. Well, now one last thing is that at least like when you are like doing things at a bit larger scale, maybe you are creating some product features. Well, how do you even know if these things work correctly? How do you know if the model works correctly? And that's of course a difficult question to answer in general. And the way how many companies do this is that you conduct A/B experiments. You compare the previous version of the model to the new version of the model, and then you analyze like which one of them perform better. And anytime you have a setup like that, what it kind of implies is that you need to be able to run multiple independent pipelines of these models in parallel, because you need the older version, like let's say you need the version A of the model, and then you need the version B of the model, and they need to be running at the same time. And again, I mean, although this doesn't seem like much, kind of now when you combine this with all those other requirements, the question becomes that does your workflow orchestrator actually support these like shadow deployments as the first class citizen? And that's what we want to do, like with this feature called Add Project in Metaflow. So now you can define that, for instance, like I have this project that may even consist of multiple workflows. It might be that I have a training flow, I have a prediction flow. Maybe they are then connected every time the model trains. I want to update my predictions and so forth. But not only that, but also I may want to have the whole like another copy of that sequence, and they should be fully isolated. There must not be any kind of interference between these two deployments. And what you can do in the case of Metaflow is that you can deploy them with different branches, and Metaflow takes care that like these things never then overlap when running in production. And this way now you can start conducting A/B experiments because you have two independent sets of results, and depending on the kind of the feature flag system, depending on your product setup, then like you can read those results and populate the kind of the UI accordingly. So basically at this point it feels that like, okay, so we have the full kind of a journey, like starting from like prototyping on a laptop, going to cloud workstations, all the way to actually like running product experiments in a production quality setup. So that's pretty cool. Now, of course, like one thing that's absolutely a fact of life is that things do fail, and things always fail, and like it's better to be prepared. And like we can almost treat these failures as a feature, in a sense that like instead of like handling them as an exception, like start thinking about the failures like all the way from the get-go. And not only it's a question that like how do we deal with the failures automatically, but it's also like this big question that like how do we debug things if something fails? Who's on the hook for figuring out what fails? And like especially like how on earth, let's say if the problem is with the model or like with the feature engineering or anything else like that's in the realm of the data scientists, how are they going to reproduce these issues locally so that they can actually fix these things? And like for those of you who have done any engineering in the past, you know that the first thing when something fails is that you try to reproduce that issue locally again, and like only when you are able to really kind of get the same problem, same crash happening again, you are like well positioned to start fixing the problem. So how do we get to that? So well, of course, like one thing is that like there are types of failures that are like absolutely infrastructure related, ephemeral. It might be that just something fails in the cloud, and these type of issues are of course like really impossible to reproduce locally, and like they are better handled automatically. So for instance, you can do this add retry, you can do this catch, which means that like whatever happens on the infrastructure side, like we will execute then like maybe some fallback code. So that's useful as the kind of the first line of defense. But then when it comes to debugging failures in the kind of the business logic in the modeling code that can't be handled automatically. Like it's really important that like you kind of have this two-way street. So as we discussed before, like you can export these Metaflow workflows to the production scheduler just by doing this myflow step functions create or argo create or airflow create. But the question is that, okay, how do you actually come back? And that's the big piece that's oftentimes missing in many frameworks. And what I mean by that is that, like, let's say something fails in production. Let's say we have this execution SFN like 199874, like that failed in production. How on earth like can you actually like start figuring out what happened, how to fix that error, and like kind of how to kind of get the same error happening locally? So now in the case of Metaflow, it comes with this resume command, which means that like you can take any existing workflow execution, including those that happen on the production scheduler, and you can just give the run ID, and then it basically takes the same state of the system and starts executing that locally. So you can imagine, let's say that maybe the data set started having nulls suddenly, and like your feature engineering code fails because it can't handle nulls. Now what you can do is that I can just resume the execution. It starts resuming from the feature engineering step, and hopefully I get exactly the same like a null error now locally. And now I can locally, without touching anything in production, I can just like figure out how I deal with nulls in the code. I make sure that that works locally, and then I can like execute step functions create again to deploy the fixed version to production. And that's kind of the type of debugging cycle that like we want to encourage. Okay. So what are the kind of the big lessons learned? So I'll absolutely like kind of a one take home message of this presentation is that the path to the production is incremental and iterative, and like very much so that like it is definitely not something that like you first hack something in a notebook and then you click a button and somehow magically things become production ready. But there are multiple steps on the journey. Like you need to think about, how do I do scaling? How do I like access data from the data warehouse? How do I think about the orchestration? How do I think about the execution environments, dependencies, monitoring, and so forth? And of course, the important thing is that not every project has to think about all these different things. Maybe your data is small enough that you never have to think about scalability, and then it's fine. Like you shouldn't be burdened by anything like related to scalability if that's not your concern. Or like maybe your thing is simple enough that like you don't have to worry about dependencies. That's fine. I mean, then you can take the simple approach. But it should be possible that like kind of basically the higher the SLA requirements for your projects, the more capabilities, the more like hardening kind of you should be able to do on your project. And really the idea is that like it really varies between projects. So let's say the recommendations might be absolutely business critical. Maybe when you're prototyping something locally, I mean, failing is totally okay. Like if you have to go through some like complex CI/CD system, I mean, just to test crazy ideas, I mean, that's way too burdensome, and that shouldn't be the case. Or like, let's say a big problem oftentimes is that you kind of have this chicken and egg problem, that you have a crazy new idea that, let's say you have a new data scientist, machine learning engineer who joins the team and has this new amazing deep learning based model architecture that like could be really promising. But like the only way to know if it actually works better than the existing approach you have is to conduct an A/B test. And you don't want to spend too much time on engineering like some highly scalable, highly available system before you even know if that's the right approach. So there needs to be a way how you can actually like create this like experimentation quality, A/B test quality kind of version of the model that like just works well enough, then so that you can conduct a test, and then you can come back and make a decision if you want to invest more. And then the other important take-home message here is that it's really the full stack that matters. It's really hard to kind of evade any of these responsibilities. I mean, you have to think about data, you have to think about the compute, you have to think about workflows, versioning, like how you architect your code, and so forth and so forth. But also that there's this natural division of responsibilities and freedom. And like one thing that like we, as you maybe saw like between the lines in this presentation, that when it comes to these modeling concerns, there's a lot of freedom at the top of the stack. And I think that this is really important. It's not so that everybody must use the same models. It's not so that like everybody, even you must use the same features. But I mean, there has to be a lot of freedom like to experiment different approaches. But it's the lower layers of the stack that then guarantee that like things actually work robustly, even in production. And now, of course, like the view that we have is that like instead of having 7 or 8 different tools like for all the layers of the stack, it is more convenient that you have a single framework like what we have been building with Metaflow. But now the important thing there is that, of course, I mean, Metaflow by itself, I mean, doesn't solve all the layers. It merely integrates with other things like Kubernetes, AWS, Argo, Spark, and so forth, but provides that user interface of sorts, not the graphical user interface, but the Python interface for data scientists to kind of build these applications. Now, I mean, since we are pretty much like running out of time, I'm just wanting to have a shameless plug that there's also a new book coming. Actually, it will be in print. It's already available on the website. You can look it up, but also it will be available on paper just in a month or so. It's called Effective Data Science Infrastructure, written by me. It talks about exactly these topics that we covered today. So lastly, we have a Slack community as many other people. So with like over now 1,000 people talking about Metaflow, talking about practical data science, machine learning across many companies, across industries. So please join the Slack. And if you have any questions, I'm happy to help you there and help you get started. So thank you. And now, yeah, it's a good time. I think we should have a few minutes for questions if you have any questions. If you want to ask questions or like later, you can join Slack and ask questions. So happy to talk anything about any framework related to data science and machine learning. It doesn't have to be even Metaflow related. So we have been like helping many companies, and of course at Netflix, like also like I saw many different approaches and like many types of questions, both related to modeling as well as the infrastructure. So anything is interesting.
Yes, I think we have one question there for you.
Mm-hmm. Let's see. Okay. Does Metaflow offer a team project management capability? Oh, that's a great question. Yeah, deep question as well. So, of course, there are like many different elements to that team collaboration. And I can just like quickly mention that like one feature that is very important there is that Metaflow has this concept of namespaces. So by default, when you execute something as your user, let's say like your name is Sam, so Sam, you execute something on your local machine, so that like gets executed in the Sam namespace. And then let's say there's someone else in your team, Alice, and when they execute something, they execute in their own namespace, and they can keep experimenting in their own namespaces. But also then like there's a way how you can like share this information. And like we felt that especially like in data science projects, it's super important that like on the one hand, like people have this like kind of a own like isolated environments where you can kind of test something and you never have to fear about interfering with your colleagues' work. But then like when it's time to collaborate, there's also like a very easy way to collaborate. So that's one aspect of the collaboration. Then the other one is actually like kind of with the ad project, like also like you can deploy, different people can deploy the production, like their different versions and branches and so forth. So that works. Now, of course, like when it comes to like other concerns, like kind of maybe more on the like authorization side, then like Metaflow relies to whatever you already have. So it doesn't come with those type of team management capabilities, but it should integrate rather nicely to kind of your overall like a business environment and how you manage people and identities. Good question.